The purpose of this video is to discuss how to solve stoichiometry problems. In stoichiometry, we use the quantity of one substance to solve for the quantity of another substance in a chemical reaction. We use the mole ratio to do this. And if you think about a bicycle, I think it kind of explains the idea of the mole ratio. In a bicycle, you have a frame, you have a seat, you have two wheels, you have a handlebar, and you have two pedals. So if you look at that as a balanced equation, there's one frame, one seat, two wheels, one handlebar, two pedals for every one bicycle. So we can look at the ratio of these parts. Example, what is the ratio of frames to bicycles? Well, that's a 1-to-1 ratio, one frame for every one bicycle. How about pedals? We need two pedals, right, for every one bicycle. So that's a 2-to-1 ratio. 2-to-1 ratio of pedals to bicycles. Now, if we're talking about chemistry, we're looking at the relationship between products and reactants in a chemical reaction. And we would use dimensional analysis to solve these problems. And the conversion factors that we could use would be molar mass, Avogadro's number, the mole ratio, like we just did, and then the volume of a gas at standard temperature and pressure. And you have a cheat sheet here. This will help you determine which conversion factors to use for whatever type of problem you're solving for. And if it's a mass problem, so if you're given the mass of one substance and you're solving for the mass of another substance in that chemical reaction, you would start here, follow the path, and stop there. And you would use every conversion factor along the way. If you're going from molecules to moles, so molecules of a substance is given to you and you're solving for the moles of the other substance, you would start here and stop there. And you'd use 1, 2 conversion factors. Today we're going to focus on mole to mole problems. So in this example, we're given 2 moles of nitrogen. We're solving for how many moles of hydrogen. So this is a mole to mole problem. Moles A, that's the substance that's given. Moles B, the substance that you're looking for. So the only conversion factor you would use would be the mole ratio. Always start with what's given. And then our mole ratio is moles B over moles A. Moles B is what you're looking for. Moles A is what's given. And we use the coefficient on the balanced equation. So moles A is nitrogen because that's what's given to us. So we have 1 mole of nitrogen. Moles B is what we're looking for. That would be 3 moles of hydrogen. So you cancel your units. That leaves you with moles of hydrogen. Then you multiply. 2 times 3 is 6 moles of hydrogen. Now sometimes you don't get the balanced equation. You have to do the balanced equation on your own. So here's an example of that. When octane reacts with oxygen, it produces carbon dioxide and water. So we're calculating the number of moles of water when we have 0.050 moles of octane. Well, octane reacts with oxygen to produce carbon dioxide and water. So there's your equation. Octane reacts with oxygen to produce carbon dioxide and water. But you have to balance it. So you have to be good at these balancing equations or stoichiometry will be very difficult. So you balance the equation and then you decide what type of problem is this. Is this a mole to mole, mole to mass, mass to particle? What is it? Since we're given moles and we're looking for moles, this is a mole to mole problem. So you start with what's given, 0.050 moles of octane, and then we use 1 conversion factor, the mole ratio, moles B over moles A. Since moles A is what's given, that's octane, we have 2 octane for every 18 water. So 0.050 times 18 divided by 2. Cancel your units. Will give you 0.45 moles of H2O.